Hi, I am presenting the child support agent. A parent of an autistic child faces this kind of moment often and has only seconds to decide. Is this something ordinary she can handle herself, or does it need real professional help? That repeated high stakes decision made under stress with no personalized support is the exact problem this project sets out to solve. We built it using Google's Agent Development Kit 2.0 with anti-gravity as my coding agent throughout, and Agent CLI for scaffolding, local testing, and evaluation. Here's why this needed multiple agents, not just one clever prompt. Two things pull in opposite directions. One side needs to be flexible since personalized suggestions require real reasoning about a specific child. The other side needs to be firm, since safety escalation has to happen every time, even if the message tries to talk the system out of it. One prompt cannot do both safely, so we split them into a separate agents with plain code, not a model, deciding which one runs. This is the actual graph, built with ADK 2.0 Workflow API. Every message flows through load profile, a security screen, then a classifier that scores severity. The key piece is severity router, which is plain code, not a model call, since we never want that one decision open to influence by clever phrasing. And notice this branch from security screen. If manipulation language is detected, it skips the classifier entirely and goes straight to the safety response. This is the real trace, not a mockup. The message comes in, gets marked clean, classified as moderate, and routed by code to recommendation agent, which responds using Sam's actual profile, something that's really worked before. This is the real test we ran against our own agent, a classic prompt injection attempt telling the system to ignore instructions and downplay a tantrum. Our security screen catches this with pattern detection before it reaches any model and routes straight to the safety response. These mechanisms here, PII reduction, injection detection, and structure security flags so the safety agent knows to ignore the framing, not just react to it. We ran a 5 case evaluation using Agent CLI evaluation framework with two custom metrics plus the built-in safety metric. These are actual results, not illustrative numbers. The safety risk case and the injection case both scored 5 out of 5. And the judge confirmed the system resisted a message actually trying to talk it out of escalating. We are also showing a real failure. A system prompt extraction query was misrouted, scoring 1 out of 5. Finding and naming our own weak points throughout evaluation is the kind of rigor this project is going for, not just claiming it works. This slide covers the remaining concept from the rubric. Anti-gravity was our coding agent throughout, generally useful for debugging, including tracing a real bug where a state object's raw Python object output was leaking into the model's input instead of the actual text. Agent CLI handled scaffolding, local testing, and the evaluation we just showed you. And for deployability, no live endpoint is needed for judging, but it's scaffolded and ready via Agent CLI's deploy tooling. To close, these concrete next steps, each one motivated directly by something real evaluation found, not a wish list. Fix the classifiers gap on meta queries, finish wiring the already working MCP server into live tool calls, add persistent memory so the system actually improves for the specific child over time. The through line of this whole project is on screen. Let the model reason where reasoning is genuinely needed. Keep the highest stakes solution as a hard rule in code and evaluate honestly enough to find our own real weaknesses rather than assume the system works. Thank you.